Hi guys. We're starting DMA 80 now in this section, and I finally have gotten some technology here that will help me be able to show you the steps in real time as opposed to just talking through the solution key. So hopefully that'll be more beneficial for you. Um, so I'm just going to jump right in. I'm looking at section 8.1. At the top here, you see that symbol, and that symbol is referred to as a radical. Most often, it's just I kind of refer to it as the square root symbol because you encounter a square root more often than you do any other root. But you can, as we'll talk here about in just a minute, that you can take the cube root, fourth root, the fifth root, and so on. But essentially, whenever we're talking about the square root, whatever is underneath that radical symbol is referred to as the radicand, and the number at the top there is the index. When you're talking about the square root, then we're assuming that the index up here is 2. Okay, and with square roots, you're asking yourself, what can you multiply times itself to get that number? So, like for example, if we had 64 in here, then we're thinking about, okay, well, what can I multiply times itself to get 64? Oh, okay, well, that's 8 times 8. Or we could say, okay, well, that's the same as 8 squared. And so what I like to do then is if I can write this as some power of 2, if I'm trying to take the square root, I want to write what's in here, a power of 2, then, or a multiple of 2, then I'll be able to, the rule is that you take that base and you take your power here and divide it by the index. So 2 divided by 2, and so then that equals just 8 to the first power, which is just 8. Which, that's just the math behind it. And I'm showing you that because when we step it up a notch here in a few moments and look at the cube root, the fourth root, and the fifth root, you're going to want to sort of have that technique in your back pocket. So with that said, I mean, I know that you probably knew that the square root of 64 is 8, or you could throw it in your calculator and get that it's 8. But when we step it up a notch, that's the reason why I'm showing you that particular step. A square root is an even root. You cannot take the even root of a negative number. I'll talk more about that in a few minutes, but that has to do with the fact that you're taking a number and multiplying it times itself. And so if you take a negative number and multiply it times itself, you're going to get a positive number. But you'll see it better in here in a few moments of what I mean by not being able to take the square root of a negative number. So we'll just look at a few of these. You still have the fully worked out solution key online for you in Blackboard. So whenever we go through the notes, I won't always do every single problem, but I'll give you enough to be able to, you'll have seen me work through the steps, and then you'll be able to probably at some point, I'd say pause the video, try a few of these, and then go back and make sure that you're tracking with the solution key. Kind of have a couple of things up at once if you can. All right, so like in this first one, the square root of 0, you're asking yourself, what can you multiply times itself and get 0? It would just be 0. Square root of 1. 1 times 1 is 1, right? The square root of 4. Remember, that's the same as the same thing as saying 2 squared. And there's a little imaginary 2 out here. So that's 2 to the 2 over 2, which equals 2 to the first, which just equals 2, which we knew at the beginning. The square root of 4 was 2. I'll do one more. Square root of 9. That's the same as, let me make this a little smaller here. That's the same as the square root of 3 squared. That 9 is the same as 3 squared. There's an imaginary 2 here. Then that's 3 to the 2 divided by 2, which is 3 to the first power, which is just 3. Square root of 9, which we know is 3. You're asking yourself, what can you multiply times itself to get that number? I can multiply 3 times itself to get 9. All right, so I'll let you try the next two. I'm going to scoot on down here to the square root of negative 36. I cannot take the square root of a negative number, okay, because, you know, if you say it's negative 6, then you're saying, well, negative 6 times negative 6, that gives me positive 36. And positive 6 times positive 6 is positive 36. So I'm never going to be able to find a number that I can multiply times itself and get a negative 36. So therefore, for that reason, this one would be referred to as no solution. So this would be no solution. I'm just going to abbreviate there. Or actually we'll say, and I'll maybe even, let me just add that in there. It's just no real solution. There are what are referred to as imaginary solutions, and you'll talk more about that in pre-calculus. Now, the difference between the negative being underneath the square root versus the negative being on the outside. So let's look at the example on the right. When the negative's on the outside, you can just bring that negative down, because essentially what that means, this is like saying -1 times the square root of 16. Okay, so -1 times, and we know the square root of 16 is 4. So final answer here then is -4. Okay, I wasn't trying to take the square root of -16. I was just saying -1 times the square root of 16. Or a lot of times I like to say, when you just have a negative outside of something, it's the opposite of that particular value. So then if we move on down to the next one, where we have the square root of 81, 1 over 81, then one big square root is the same as two small ones. So you have the square root of 1 over the square root of 81. The square root of 1 is 1. Square root of 81 is 9. And then I'll let you try the next one. It's another square root like that. On the next one, with the square root of 0.0049, I would just, if I were you, I'd just put that in your calculator. You're going to find it comes out to be a perfect 0.07. Square root of x squared. So this is where I've kind of been showing you that technique of having the little 2 out here. As long as your power is a multiple there of 2, then you can say, okay, well, this is x to the, I'm taking the 2 on the inside and dividing it by the 2 on the outside. So 2 divided by 2, okay, that's just x to the first power, or just simply x. And then if we move on down to the next row, as long as they are even powers, we can just look at it here. Okay, oh, this is the second root. So as long as it's an even number, then this is the same as x to the 6 divided by 2, or x cubed. Okay. I'm going to let you try the next one. You'll be taking the square root of 121. We're taking the square root of z to the 8th. Let's get on over to the next one. Not all of these values here are even. What you want to do then is let's make them the highest even that we can. So like a to the 5th, wouldn't you agree that I could write that as a to the 4th times a? All right, so I still have 5 a's in there. I'm just writing it a little differently. B squared is even, so I'm going to leave it alone. I want to be able to divide by 2. Okay, that's my goal here. C to the 7th, couldn't I write that as C to the 6th times C? I still have 7 C's in there. I'm just rewriting it a little differently. And then I have D. So now I go through and take the square root of the items that I can. So I'll be able to take the square root of all the ones that I can take half of. So let me so here for a to the 4th, so that would be a to the 4 divided by 2. Okay, so and then I'm just going to leave my square root over here. This other a I can't take. That would be like a to the 1/2, so it's not going to be a perfect one. So I'm going to leave that a on the inside. B squared, I can bring that out, and that would be b to the 2 divided by 2. So that one's gone now. That one's gone. C to the 6th, that would be c to the 6 divided by 2. And then I'm left also in here with a C and a D, because I wouldn't be able to take half of those. Like they would, if you want what's on the outside to be perfect whole numbers. And from here I can simplify so that I have perfect whole numbers, because 4 divided by 2 is a squared. 2 divided by 2, that's just going to be a regular b. 6 divided by 2 there is going to give me cubed on the square root of a, c, d. Okay, so that's the final answer there. Okay, let's look at the next one. All right, so one big square root is the same as 2 small ones. So I'm going to rewrite this as the square root of 144. And since it's the 2 out here, then I'm going to think of, okay, what's another way I can write y cubed? I can write that as y squared times y over, and then I would have the square root of z to the 10th. And since that's even, I'm going to leave it there. I'll be able to take that square root like I need to. All right, so now I'm going to go through and take the square root. So the square root of 144, that's 12, so it's outside. Square root of y squared, that's y, so it's on the outside. This other y sitting here is going to stay on the inside. And then on the bottom, the square root of z to the 10th, that's z to the 10 divided by 2, or z to the 5th. And then that would be your final answer. If you want to still write that little 2 up here on the square root, you certainly can, okay? Now, sometimes we aren't able to, they're not perfect square roots. So in that case, you want to think about what your perfect square roots are. And so I'm just going to I'm going to generate a list here for you. So your perfect square roots, remember, so you know 2 squared is 4, 3 squared is 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7, 8 squared, 64, and so on. You get the idea, right? So I can have 9 squared. I can keep going, okay? I can go 10 squared, 11 squared, so on, okay? 27, I look for the highest number in this list here, the 4, 9, 16, 25, and the 36, 49, 64, 81. I look for the highest number in that list that will divide evenly into 27, and hopefully you would agree that 27 is the same as 9 times 3. Now I know that I can take the square root of 9, and so the square root of 9 is 3, so it comes outside the house, and 3 stays inside. So 3 square root of 3, final answer. Square root of 28. I look for the highest number in my list, and so let me kind of reiterate my list here. So my list is 4, 9, 16, 25, 36, 49, 64, 81. These are numbers that I can take the perfect square root of. So I look for the highest number in this list that will divide evenly into 28. And so hopefully you would agree, oh, well, 4 will. So 4 times 7. Now the square root of 4 is 2, so 2 comes outside the house, 7 stays inside. Okay. Let me give you another one. I know these are a little bit more challenging. So like, for example, if I had the square root of, let's say, 72. And I look for the highest number in this list that will go into 72 evenly. And I believe that should be 36. So you just do like 72 to start dividing by these numbers. You say, okay, 36 will go into there. So that's the same as 36 times 2. Now we know the square root of 36 is 6. So 6 comes outside the house, 2 stays inside. Final answer. Okay. Now let's say, for example, you start at the very beginning and you say, well, 4 will go into it. Why don't I just go with 4? It's certainly okay. So let me show you what that would look like if you started with 4. So let's say you start here with your square root of 72 and you say, okay, well, that's the same as 4 times 18. 4 times 18 is 72. And I know the square root of 4. Square root of 4 is 2. So 2 comes outside the house, 18 stays inside. But I can't stop here because my number 18, there's still a number in my list up here that will go into 18 evenly. And hopefully you would agree that 9 would go in there. So I can just break down further. So this is, okay, well, 18 is the same as 9 times 2. Now you take the square root of 9. Square root of 9 is 3. Multiply it times the 2 that's already sitting out here, and we have 6. And then you leave that other 2 inside, just like from before. So you can get to that final answer multiple ways. But if you look for the highest number in this list, those are your perfect squares, then it'll get you there quicker. Okay. All right. So let's flip it on over to the next page. On the next page, I just have you approximating using a calculator. So usually the square root button on a lot of calculators is a second feature. So if you're in the TI 83, 84 calculators, you would hit second and then x squared in your calculator. You'd hit the second button, which is at the top left underneath y equals, and then x squared is beside the comma. And so second x squared, and then you would type in 11. You would get approximately here. I've got you rounded to the thousandths, so that's going to give you 3 decimal places. So hopefully you agree with 3.317 if you were putting that in your calculator. So this might be a good opportunity. Pause the video. Make sure you can put the square root of 30 and square root of 31 in your calculator and get those answers. If not, reach out to me and I can give you some screenshots of a calculator to help you out. Okay. All right, if we move on down then to the next piece, it says, well, approximate square roots using logic. So for example, I'm just going to look at the example over here on the left, but you could try the example over on the right by yourself. So the square root of 4, we know that's perfect. That's 2. And the square root of 9 is 3. That's a perfect one. So then if we want to know the square root of 7, it's not a perfect one, but we do have to know then that it has to be somewhere between 2 and 3. Does that make sense? It's got to be between 2 and 3. And so to figure out what that value is, we would just simply go to our calculator. So second x squared, type in 7, and you get 2.646. So it's approximately 2.646. And so if you were in your calculator, did 2.646 and squared it, you get 7.00, and then you get 1316. And you're not getting it perfect because we rounded here. But if we had taken our answer and then squared it, we would have gotten the perfect 7. All right, so at the bottom of this page, we start talking about higher roots, the cube root, the fourth root, the fifth root, and so on. But I think actually mostly everything down here, actually all of this down here, excuse me, is just the cube root. So the cube root then is you're looking for what can you multiply times itself 3 times to get that number. I will make a note for here for yourself, highlight it for you actually, that you can take the odd root of a negative number. That is legal. You can't take the even root of a negative number, but you can take the odd root of a negative number. And that has to do with the fact that, you know, for example, if we had the cube root of, let's say, -8. Well, -8 is the same as -2 times -2 times -2. Does that make sense? Right? -2 times -2 would give you +4, and +4 times -2 is going to give you your -8. So you're asking yourself, okay, well, what can you multiply times itself 3 times to get -8? Oh, I can multiply -2 times itself 3 times to get -8. So therefore, the cube root of -8 is -2. Again, you can take the odd root of a negative number. You can't take the even root of a negative number. Okay. All right, so if we look on down then at that first one, the cube root of 8, and as I just talked, you know, this one's just positive, so that's going to be 2. So for the next one, the cube root of 216, we're asking ourselves, what can we multiply times itself 3 times to get 216? And so, so really what that would be is you could multiply 6 times itself 3 times. That 6 cubed, like you could check in your calculator, 6 raised to the 3rd power is 216. And so therefore then that would be 6 to the 3 divided by 3, which is 6 to the 1st, which is just 6. The cube root of 216 is 6. You have a cube root in your calculator. Give me just a second. If you've got that TI 8384, let me find it real quick. I believe it's math. Yep, it's math. You hit math. Math is right underneath your green alpha key. And then it is number 4. And then you can type in 216, and then it will tell you a 6. Okay. So likewise on the cube root of 343, you'd be able to type that one in directly. Let's scoot on down then to this next one. We have negative the cube root of -27. So I can take the cube root of a negative number. So, and remember this negative on the outside is like -1 times this value, or the opposite of. So maybe it's easier just to think of it as -1 times the cube root. What can I multiply times itself 3 times to get 27? So that would be 3 times 3 is 9. 9 times 3 is 27. So 3 cubed would give me +27, but since I want a -27, it would be -3 cubed. So then I still have my -1 out here. The cube root of -3 cubed is just going to be -3. And then multiply that together and you get +3. Final answer. Okay. I'll let you try the next one. And then, oops. Sorry. There we go. Get it back in the right spot. Let's look at the bottom row here. So the cube root of x to the 9th, just like I was showing you on the previous page, this would be the same as x to the 9 divided by 3. And so that would be x to the 3rd power. Final answer. So if you're taking the cube root, you want everything in underneath there to be, in terms of letters, to be multiples of 3. So so for example, on the next one, the cube root, and likewise, a cube root of this division is really too small, and so this is like the cube root up top of 125z cubed divided by, on the bottom, the cube root of 512. And so now up top, what can you multiply times itself 3 times to get 125? And that would be 5. Cube root of z cubed would just be z. On the bottom, what can you multiply times itself 3 times to get 512? And that would be 8. 8 to the third power would give you 512. And that's your final answer. All right, so then on the next one, we have the cube root up top of -8. Y to the fourth, I want to write that in terms of multiples of 3, so I could write y to the fourth as y cubed times y. And then on the bottom, I can write that as the cube root. And 6 is already a multiple of 3, so I can just leave that one alone. So now up top, the cube root of -8, what can you multiply times itself 3 times to get -8? Hopefully you agree with that's a -2. Cube root of y cubed would just be y. And then I have left inside the other y. And then on the bottom, the cube root of z to the 6 would be z squared, because that would be 6 divided by 3. And that would be your final answer. You have to have that 3 there on the cube root of y, because otherwise it indicates that it's the square root. So you do need that. All right, flip it over then to the next page. And these are some higher index roots. So like the first one, the fourth root of 625, you're asking yourself, what can you take, what can you multiply times itself 4 times to get 625? Let's see, I know your calculator, it's number 5. I got to figure out how that works. I find the easiest way for me personally to put these in my calculator would be, this is 625 and it's raised to the first power. It raised it to the 1/4 power, but in parentheses. So it would be 625 raised to the parentheses 1 divided by 4, if you're going to do it in your calculator. So that would equal 5. That's one way to do it. Another way to think about it, though, is that the fourth root, 625, 5 to the 4th power is 625, and so then that's the same as 5 to the 4 divided by 4, which is 5 to the 1st power, which is just 5, like we got before. Okay, so like on this next one, we would be asking ourselves, what can we multiply times itself 5 times to get 243? And so that would be the 5th root of 3 to the 5th power, and so that would just give us 3. If you wanted to put it in your calculator straight away, it would be 243 raised to the imaginary 1 right here, so the 1/5 power. You got to put 1/5 in parentheses. Okay, that's important. On the next one, the 6th root of a negative number. This is an even number, so you can't take the even root of a negative number. So can't take the even root of a negative number. It's going to abbreviate. Okay, so therefore here you have no real solution. You'll have imaginary solutions that you'll talk about when you get to pre-calculus, but right at the moment we don't have any real solutions. All right, let's see, let's scoot on down over to let's look at this one here in the center, the 5th root of -32. Okay, so I can take an odd root of a negative number. So, and again, you know, if you want to, in your calculator, you could just simply do -32 raised to the 1/5 power, like that. And that should tell you that it's -2. And then for these exponents here, they're already multiples of 5, so you would do 10 divided by 5, so that would be x squared. And y, 15 divided by 5, so that'd be y cubed, and that would be your final answer. Okay, and then the last one, the 7th root of 384. So 384, I don't believe is going to be a perfect 7th root. So if you raise 384 to the 1/7, yeah, we get a decimal number. So we got to think about this one a little differently. 384, since it's even, let's figure out what 2 to the 7th is. 2 to the 7th is 128, and 384 divided by 128 is 3. There we go. All right, so let's think about it this way. Then 384 is the same as 2 to the 7th times 3. And again, 2 to the 7th is just 128. So from here, and then x to the 21st, I can leave it alone because 21 is already a multiple of 7. I'm doing the 7th root here. So the 7th root of 2 to the 7th is just 2. The 7th root of x to the 21st, so 21 divided by 7, that would be x cubed. That comes outside, so these two pieces are coming outside the radical, and then I'm leaving the 7th root of 3 inside as my final answer. That's a tougher one. Personally, I'm going to stick you with mainly doing ones that are like your square root and your cube roots, and because that would be challenging in the pre-calculus as well. So all right, so let's scoot on down then, but it sort of gives you an introduction to it nevertheless. You can also evaluate square and cube root functions. So in letter A here, if you want to find f to this, they're telling us f of x equals the square root of x squared plus 1. If we find f of 6, that just means everywhere you see an x, plug in 6. So I'm looking at the square root of 6 squared minus 11. Okay, so that's the same as the square root of 36 minus 11, or the same as the square root of 25, and the square root of 25 is 5. Okay, the next one, square root of f of 11, so that would be the same as the square root of 11 squared minus 11. So the square root of 121 minus 11, or the square root of 110. Now you would think about your list. Remember that list that I had from before on the previous page or front page? It was 4, 9, 16. Let's see, that's 4 squared. 5 squared is 25, and so on. You would start to divide 110 by numbers in that list. Unfortunately, none of those numbers will go into this number. So therefore, a square root of 110 is your final answer. And then we'll do the last one here. F of 3, everywhere you see an x, plug in 3. So you have 3 squared minus 11. So that's the same as 9 minus 11. And that's the square root of negative 2. And then that's not going to be your final answer, because remember, you can't take the square root of a negative number, so this would be no real solution. Or just no solution. Okay, and then I'll let you try the example down at the bottom. I don't think there's anything too new down there other than the fact that you're taking the cube root, but they're straightforward cube roots. And then the back page is just practice with everything that we've talked about here in this set of notes, so I think that'll be a good practice for you. Definitely reach out and let me know if you want me to work out anything specific for you, and I will look forward to hearing from you. Thanks a lot. Bye.